Hello everyone, this is Team 11 with group member Leiken and Gong Yiqian. Today we are trying to use machine learning methods to try to add value for airline companies. The airline company satisfaction has always been a very hot topic because airline companies want to attract as much customers as possible. However, in the same time, they want to reduce their costs. So how to find the key factors that will influence the customer satisfaction and trying to minimize the cost is the main focus of today's lecture. So our content would be in these 6 parts. The first is task performance measure and training experience, second data set, then exploratory data analysis, the model, and how to add value, use the cost optimization, and finally, the discussion and next steps. So the task here, as we have just classified, it is a classification of customer satisfaction based on their personal status and the airline performance. The performance measure we choose here is a precision and F1 score. This is because in our mind, in this case, if a customer is predicted to be satisfied, but is not actually satisfied, then it will cause this problem for the airline company to find where their main problems are and to make potential improvements. So we need to focus on reducing the value of false positive values. However, we also wanted to reduce as much false negative values as possible. So F1 score is also a key issue we would consider here. The training experience we will use here is a data set of the past customer and airline information. The airline satisfaction data set we already have in total 129,880 records. We have 22 customers and their corresponding airline features for predicting their satisfaction. And the customer satisfaction is indicated by either satisfied or dissatisfied. Our data is almost balanced. We have about 54.7% records of satisfied and 45.3% records of dissatisfied. Now I will introduce Lei to do some exploratory data analysis.
Okay, so next part is about some exploratory data analysis on the data set. First, when we look at the data set, we immediately find that there's missing data for arrival delay. So in order to handle that problem, we decided to check if there's any relationship between departure delay and arrival delay. And in fact, it turns out that they have a strong linear relationship. Because we have an overwhelming number of flights without any delays, we look at them specifically with the histogram on the right side. Again, if a flight does not have a departure delay, it will most likely to arrive without any delay. Based on the above 2 findings, we decided to fill the missing arrival delay data with corresponding departure delay data. Next, we explored some relationship between satisfaction and some variables in the dataset. There's only some example variables are shown here. Overall, the airline has slightly more satisfied customers than dissatisfied customers. But on the other hand, female customers have shown higher satisfaction level than male customers. Besides, all the service provided by airlines do have an impact on the overall satisfaction. Customers are more likely to be satisfied with better services.
Okay, now we turn to the part of training the model. We choose to use 20% of the data as a test set and 80% as a train set. The features, we have both features, number features, and text or categorical features. For the categorical features, we use the one-hot encoding methods on them. And the features are mainly divided into three categories. They are customer features, flight features, and customer ratings on the flight features. The classifier we choose to use here is the perceptual model, the logistic regression model, the decision tree model, and the random forest model. we use the tenfold cross-validation to optimize the parameters we would use. Here are the model performance for all of the 4 classifiers. And we can see no matter from the precision perspective or the F1 score perspective, the random forest classifier is always the best choice for us on this data set.
After we have finished our model training, let's see how we could add value for airlines using our model. Based on the variables that are included in the machine learning algorithm, we can classify variables into 3 different categories. The first one is customer variables. Every customer has its own set of customer variables, such as age, gender, and these cannot be adjusted by the airlines. And the second variable is flight variables. Every flight has its own set of flight variables, such as distance and delay, and etc. These are generally fixed and cannot be adjusted by the airline in a short time. And last, we have service variables. This represents all the services provided by the airline and can be adjusted by the airline. Service variables are the only adjustable variables, and because different services have different cost levels, finding the optimum combination of service levels to minimize the cost while maintaining the customer satisfaction is the key to our solution. Due to the machine and dataset constraints, we have made the following simplification process. First, instead of cost optimizing for the entire flight, we do cost optimization for a randomly chosen customer in our dataset. Second, instead of using 11 variables with 5 or 6 levels, we selected 3 variables for the grid search optimization. And last, because actual costs are hard to obtain, we will assign a linear cost function for each service. And below is our comparison for cost optimization. While the actual figure will vary from our results, this is just for demonstration purpose, and we could still see that there is opportunity to cut down the cost while maintaining the customer satisfaction level. Our next part is a review of our project. First, our model takes into account of customers' characteristics. Although this means our model have to predict for every individual customers, it also means that we can do cost optimization for a certain group of customers instead of the entire base customers if it is necessary. Second, our model consists of 11 service variables and 5 to 6 levels, which makes it grid search for cost optimization impossible. And third, well, we assign a linear cost function for each service. In real life, the airlines should be able to obtain such data internally. The next to do for us is, in order to address the problem 2 that I mentioned above, we will first have to try feature selection or feature engineering to limit the number of features and make grid search possible. Or we have to find a suitable optimization algorithm for this problem. That's the end of our presentation. Thank you for watching.